Okay, so we're taking a look at 2015 free response questions, AP Calculus. Number 4, consider the differential equation dy dx equals 2x minus y. On part A, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. Okay, do you remember how to find a slope field? Alright, so what we're going to do is we are just going to take the points and plug them into 2x minus y. Okay. Alright, so how we kind of do this systematically if we can. What I would probably do first is I would find all the points that are along this line. Okay. And along all those points, the x-coordinate would be 0. So dy dx for x equals 0 would be 2 times 0 minus y, so this would just be negative y. So it's the opposite of the y-coordinate. So at 2, it would be a slope of negative 2. Let's make it a little bit steeper. At 1, it would be a slope of negative 1. 0 is not on there, but at negative 1, it would be a slope of positive 1. Okay? Okay, and then I would do the slopes for all the places that x equals 1, so 2 times 1 minus y, or just 2 minus y. So 2 minus 2 for the point that's up here. 2 minus 2 would be a slope of 0. Oops. Okay, and then 2 minus 1 would be a slope of positive 1. There's not one at the x-coordinate of 1. And then down at the bottom there, 2 minus negative 1 would be a slope of 3, so this one should be the steepest of all of them. Okay? That's your slope field, just plugging in the points into the derivative. And try and do those systematically to save you a little bit of time, otherwise you're going to have to plug in each of those individually, which would not be ideal. Okay? Part B, find d squared y over dx squared, which is just the second derivative in terms of x and y, and determine the concavity of all solution curves for the given differential equation in quadrant 2, and give a reason for your answer. So for part B, find the second derivative. So dy over dx equals 2x minus y. So when I take the second derivative, we're taking the derivative with respect to x. Okay, so the derivative of 2x would just be 2. The derivative of y with respect to x would be dy dx. Now this is maybe where it's a little bit tricky because we have to take the dy dx and we're going to substitute that in. Okay, so d squared y over dx squared equals 2 minus 2x minus y. Simplifying it, 2 minus 2x plus y. Okay, so that's my second derivative, but I don't think that's everything it wanted us to do, right? It said find the second derivative in terms of x and y, which we did that, and then determine the concavity of all solution curves for the given differential equation in quadrant 2, giving a reason for your answer. So in quadrant 2, okay, so that's this quadrant here, all right, in that quadrant the x values are negative and the y values are positive. Okay. So if we kind of reason through this, right? So 2 minus 2x plus y, we have to figure out what this is equal to. Okay, or we have to reason with it somehow. So y will always be positives. Negative 2 times the x values will be negative, so this would be times a negative number. Okay, and then this was a positive number. And then 2, so we have 2 minus 2 times a negative number plus a positive number. So 2 plus 2 times some number, right? Because the two negative signs would cancel out with each other. And then plus another positive number. So what can you tell me about all of that? Right? If all the numbers are going to be positive, then we're going to end up with something that's positive. So 2 minus 2x plus y is greater than 0 in quadrant 2 because x is less than 0 and y is greater than 0. So all solutions are concave up because the second derivative is greater than 0. Okay? All right. Part C. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have a relative minimum, relative maximum, or neither at x equals 2? Justify your answer. Okay, so how do we determine if something has a minimum or maximum? A couple different ways. We could look at the graph of the derivative, but we don't have that here. But generally speaking, when we're trying to figure out if we have a minimum or a maximum, we need to look at the derivative. So dy dx of 2x minus y. Okay, and we're going to figure out, is the derivative, what's the derivative value at this point, at 2, 3. Okay, so let's go ahead and plug that in. So 2 times 2 minus 3, which would just be 1. All right, so if I had a maximum, right, at the point 2, 3, what would be the derivative at that value? Well, that's a derivative of 0. If I have a minimum, the derivative at that value would also be 0. So in order to have a minimum or a maximum, my derivative would have to equal 0, which it doesn't. So at 2, 3, we have neither, we'll say is neither a min nor a max, because the derivative at 2, 3 does not equal 0. Okay, so that's it for part C. For part D, find the values of the constant m and b for which y equals mx plus b is a solution to the differential equation. Okay, so y equals mx plus b. Oops. That's just your equation. It looks like the equation of a line. So they're saying that if you solve this differential equation, 2x minus y, then your solution would be y equals mx plus b. Okay? So let's kind of reason through this problem. All right? Y, right? If I took the derivative of that, I would get dy over dx. And the derivative of this, right, mx plus b, the derivative of that is m, right? The derivative of mx would just be m, and the derivative of b would be nothing, okay? So now that I found the derivative, I have a dy dx here, and I have a dy dx there. So because those two things mean the same thing, they represent the same thing, we're going to set them equal to each other. So m equals 2x minus y. Okay, so what we're going to do is let's take this equation we just found using the substitution and solve it for y. Okay, we could try solving it for a different variable, but notice how this equation is already solved for y. So let's go ahead and solve this one for y and see what happens. Okay, so let's add the y over and then subtract the m. So now I've got two equations that are both equal to y, so let's go ahead and set them equal to each other. Mx plus b equals 2x minus m. So there's a couple different things that we can kind of observe from this equation, right? In order for these two equations to be equal to each other, the numbers in front of the x have to be equal, and the numbers that are off by themselves need to also be equal to each other, okay? So I kind of got two equations here, right? I've got m equals 2, and I've got b equals negative m. Well, m equals 2 is already solved, right? Because now we know what m equals. So what I'm going to do is I'm going to take that m value and plug it into the other one. So b equals negative 2. Okay? And it says, find the values of the constants m and b for which is a solution to the differential equation. Well, we found the m value. We found the b value, so that problem's done. Okay, a little bit tricky, matter of determining what exactly they're asking for, but we can do it. Okay, so as far as points are concerned, on part A, you're going to get 2 points. Slopes when x equals 0 and the slopes when x equals 1. 1 point for this column of work for all those derivatives, 1 point for all of these, okay? All right. Part B, find the second derivative, that stuff. 1 point for your second derivative, 1 point for the conclusion, or concave up with reason. So as long as you said concave up because of some reason, and the reason's accurate and correct, you're going to get your point for that one. For part C, you're going to get 1 point for considering the derivative value at 2, 3, and then 1 point for your conclusion with justification. Okay? Part D, 1 point for finding the derivative of y here equaling m, 1 point for setting those equal to each other, and then 1 point for your answers. Okay? All right. Let me know if you have any questions.